Okay, in this video I will solve second question from a practice questions for the final on auctions. So it will be this question value split in a second price auction. Okay, so let's see what the question is about. We have second price auction, we have two bidders. Their values are pretty simple, so they can only take two values, 1 and 3, with probability 1/2. The value of the object for the seller is 0, and all the standard rules. All right, so let's capture the information. We have two bidders. V1 and V2 belong to set of 1 and 3, and for both bidders they appear with probability 1/2, so equally likely. All right, so we are asked to solve effectively to investigate how the value created in this auction from this transaction is divided between sellers and bidders. Okay, so we will solve these questions kind of using similar logic as we used in question 1 by doing a table and kind of carefully investigating what's going on. So first of all, again, even though the question doesn't ask us, it's a second price auction, so bidders will beat their values, right? Therefore, we can say that bidder 1 will beat his value and bidder 2 will beat his value. Therefore, we can analyze this auction by just looking at the table. So we only have two outcomes, so we'll only have four possibilities: 1, 1, 1, 3, 3, 1, and 3, 3. All of them happens with probability of 1/4. So again, like the previous question, we have all the possibilities. And again, I can verify that I aligned up all the outcomes here correctly by summing these probabilities. The reason it's 1/4 is because the joint probability is that simultaneously V1 equals to 1 and V2 equals 1 has to be the product of corresponding probabilities. So it will be 1/2 times 1/2, which is 1/4. All right. So in part A, we ask to calculate expected value created in this auction. So let's do it basically using the same logic, our table logic. So this will be value. So effectively, so think about it as part A. Well, I wouldn't write it as part A, but let me kind of capture it here and let me see how I denoted it in my solutions. Okay, so E value. All right. So there's no reserve price. So because there's no reserve price, there always will be a value because item will be sold and one of the bidders will get it, and bidders have value for it, seller doesn't, right? Therefore, value is always created. The question is just figure out how much of it created. So value will be the value of the object to the bidder who won it, which means the winner. Therefore, when it's tie, one of them will get it, but no matter who gets it, here, value will be 1. Now, if we in the second case, then bidder 2 will get it, his value is 3. Here we get 3. And finally, again, there is a tie here. It doesn't matter who gets the object here because the value of the winner would still will be 3. Therefore, our expected value is expected value of this random variable, which is, again, we can simply calculate by taking the sum. This is 10 over 4. So 2.5. So in expectation, this is how much value this auction will create for society. So in parts B and C, we will be looking at how this value, how this economic pie is divided between bidders and seller. Okay, so in part B, we'll be calculating revenues. This is basically the part of the pie for the seller. Seller gets how much? So when it's 1 and 1, seller will get 1. When it's 1 and 3, seller will get 1. Remember, it's a second price auction, so you get the lowest bid as a seller. 3, 1, the seller gets 1. And finally, when it's 3, 3, seller gets actually 3. So this was part B, and this is part C here. Expected revenue is 1, 1, 1, 6. So we have 6 over 4, which is 1.5. Is it 1.5? No, sorry. Oh, it is. Right, it's 1.5, right? 4 to 4. Yeah, 1.5, sorry. Should trust myself more. Okay, so let's see how much it is over total. If total economic pie is 2.5, the seller gets 1.5 of it in expectation that share of the seller will be 1.5 divided by 2.5. That's 15 over 25, or 3 over 5, and 6 over 10. So this 60%. So we know that seller captures 60% of this of the expected economic pie in this case. And now let me actually kind of run out of space a little bit. So I'll erase this B and C answers since we already derived them, but we'll keep them in our mind, and we will calculate payoffs of bidders. So this will be payoff bidder 1, and this will be bidder 2. Okay, and so this will be basically equivalent to the calculation you were doing in the problem set with for the auction with the entry. So here we have to calculate payoff of bidders. So notice there's a little bit of ambiguity here in a sense that we don't know who wins here when the bidders are tied. So the question is how can we even calculate the payoff? But it actually doesn't affect the end result, because no matter who will win here, he will pay the full price to the seller, and therefore both bidders, no matter who is winning, will end up with a zero surplus, because you're either losing and then you're getting 0, or you're winning, you're getting an object which is you value at 1, and then you pay 1. Therefore, in the end of the day, you're still at 0. So both bidders' payoffs in the first case will be 0, 0. Now, when it's bidder 1 bids 1 and bidder 2 bids 3, bidder 2 will win. He will pay 1. Therefore, his payoff will be 2. So that's for bidder 2, 2, 0. Bidder 1 loses, bidder 2 wins and gets 2, because it's 3 minus 1. So we'll get 2, 0 symmetrically for the fourth case, because then bidder 1 wins, gets 3, pays 1. Therefore, bidder 2 gets 0, bidder 1 gets 3. And again, we have a tie here, but it's the same case as it was here. So no matter who wins, you would still have expected payoff of 0. Okay, so that's our outcomes for the payoffs, and therefore expected payoff of player. So this will be which part? A, B, C. So expected payoff for, let's say, bidder 1. You just interpret it as a payoff. Will be simply 2 over 4, which is 0.5. Which makes sense. Remember that we expected pi is 2.5. Seller gets 1.5, and then both bidders are symmetrically, so they both get 0.5. Therefore, we already knew that bidders have to get 1, because 2.5 minus 1.5 is 1, and they just split it between themselves equally. So, and we know this is 20%, because we know seller gets 20%, 60% seller gets 60%, and 40% are left for bidders, and bidders split it 50-50. So in expectation, when bidders are thinking about potential value of them entering the auction before they know which value they are in, right? That's important, because in a sense, if you know that your value is 1, your expected payoff will be 0, because you know that you will either win and pay the price, or you will lose. Versus when you don't know what your value will be, it's still 50-50 for you. It can be 1 or 3. You know that in expectation, you will get out 0.5 from this auction. Therefore, maybe it's worthwhile entering for you. Okay, so that's question 2. So I think we got all the numbers correctly. So let's stop this video.